Hello everyone, this is Kruti Patel from Pharmaceutical Technology Department, LJ Institute of Pharmacy. In this video, we are going to cover another two dryers. That is, first is spray dryer and second is fluidized bed dryer. Let's begin with the spray dryer. Let's catch words. Spray dryers. Sorry, spray dryer. Okay, now what is spray dryer? What it should be doing? That means a solution or any material will be sprayed. Okay, that will be sprayed in form of droplets from atomizer. What is now? Here comes the question. What is atomizer? Atomizer means nozzle which is having a disc-like structure which will be rotating. It will be having pores. That disc will be having small pores through which liquid will be coming out. It is very much similar to your shower. Okay, bathing shower is very similar to that atomizer. Just the material will come with the pressure, and the second thing, the atomizer will be having very less pore size. Okay, so yes, there will be an atomizer through which liquid will be coming out in form of drops like this, small drops. Okay, so liquid will be coming out in form of small drops. Now, the small droplets of liquid will dry before that reaches to the ending wall of the dryer. Okay, and at the end you get free flowing powder. That is the main principle of spray dryer. Okay, so you are spraying solution, you are drying your powder. Yes, so most importantly, to use any material or to dry any material in spray dryer, your product should be in liquid or uh, semi-liquid. It should be in liquid or semi-liquid form. Okay, that is important criteria. Okay, so before moving to principle, let me explain you diagram. Okay, first we will be learning diagram. So this is spray dryer. This chamber which you can see, that is a spray dryer. This is cyclone separator, and this is product collector. Okay, so only this much part is spray dryer. Now, your spray dryer has two inlet. That is important part. You have to remember. First inlet is for hot air, and second inlet is for liquid feed. Okay, hot air. Here another device will be attached through which you'll be getting hot air, and that hot air will be passed. Now this liquid feed. Here it is liquid feed. Now that liquid feed will be that will be connected with the atomizer. This is atomizer. Okay, here it is a disk. This is atomizer. Here it is having disk. Now that atomizer will be rotating in a radial path like this. So what happens? The helical path of droplets means that rotating disk or atomizer creates helical path of the particles, and because of that helical path, the traveling path for any material, for any particle will increase. Okay, traveling path for any particle will increase, and that will get dry before that reaching to this part, before that reaches to this part. Okay, so this is actually the spray dryer. Okay, now let's understand the principle. In spray dryer, the fluid to be dried is atomized into fine droplets which are thrown radially into a moving stream of hot gas. The temperature of these droplets is immediately increased, thus they get dried immediately in the form of spherical particles. This process completes in a few seconds before the droplets reaches the wall of the dryer. Okay, as I said, the particles will be totally dried before they reaches to this point. Okay, sorry. Now I'm not going into construction, that I have already explained. Working, if you look at the working, I have already explained you working, but for the writing purpose, you have to divide working into three parts. So drying of material in spray dryer involves three stages. First is atomization of liquid, second is drying of the liquid droplets, and third is recovery of the dry product. Okay, so atomization of liquid, the important part is rate of feed. Okay, you have to control rate of feed in such a way that the product should be completely dried before reaching the walls of the drying chamber. At the same time, the product should not be overheated. Okay, if your rate of feed is too slow, then what happens? Your product will get dry. Okay, this is, suppose this is your chamber, okay? So if you have very slow feed rate, what happens? Your product will dry before that reaches to this point, right? But what happens? Sometimes overheating can be done. So it should not be too slow, it should not be too fast, it should be optimum. Now, second part, drying of the liquid droplets. The surface of the liquid droplets is immediately dried to form a tough shell. Further, the liquid inside escape by diffusing through the shell at a particular rate that we have already discussed in theory of drying. The temperature of air should be optimum. Again, as I said earlier, the rate of feed is important. Otherwise, what happens? Overheating may take place. Same way, the temperature of air should be optimum. Otherwise, overheating might take place. Okay. Now, next, last is recovery of product. So, what I have written, centrifugal force of atomizer drives the droplets to follow helical path, as I told you earlier. Particles are dried during their journey and finally fall at the conical bottom. Once they fall at the conical bottom, what happens? They are carried to cyclone separator where they are separated and finally to the product collector. Okay, this is how the spray dryer works. If you look at the uses, the important is it is used for the thermolabile and hygroscopic materials. Why thermolabile material? Because the contact time is very less. Contact time of particles with the heat is very less. And why the rate of drying is faster? Because product is in very small, means product is in droplet size, very fine size. That's why the rate of evaporation will be faster and drying will be faster. That's why you can dry thermolabile material because the contact time with heat will be less. It is also used for the products undergoing chemical decomposition. Same mechanism why that can be used for products undergoing chemical decomposition. And the other products which can be dried using other products which can be dried using this method is acacia, boric acid, coffee extract, citric acid, fruit juices, milk products, vitamins, plasma, serum, starch, chloramphenicol succinate, calcium sulfate, etc. So wide range of products can be dried by this method. Now, here comes a very important question. As I had mentioned in the last video, that you have to remember uses because questions might come from the uses. Say, for example, sometimes it is asked, explain the dryer which are used to obtain milk products. Okay, in this case, you have to mention all the equipments which are used for the production of milk powder, and then you have to explain any one of them. You can explain of your own choice. There is no specification, but you should remember which are the equipments that are used for the specific production. Okay. Advantages, if we talk about advantages, yes, it is a continuous process, it is a rapid process, labor cost is low. Why labor cost is low? Labor cost is low because that combines the functions of an evaporator, crystallizer, a dryer, size reduction unit, and a classifier. So many things together. How many? Evaporator, crystallizer, two, third dryer, fourth size reduction unit, and fifth classifier. Okay, so you can have number of functions together. So labor cost, that's why decreases. Once you load the material, and you have your final product means that can include this five process, so no labor cost is required, right? Low labor cost is required. Using suitable atomizer, the product of uniform, sorry, okay, yes, here it is, sorry. Yes, the product of uniform and control size can be obtained. How uniform and control size? Because the feed material is coming out through atomizer specific disk, which is having specific pore size. So each and every particle will be having same size. Okay. And yes, you can also set the size of that particle by changing the pore size of atomizer, right? So you can have uniform and control size product. Then the product which are dried by this method shows excellent solubility. Why excellent solubility? Because the product will be more porous. First it was in solution form, then it is converted into solid form. So what happens? Air particles gets entrapped into product. Your product will be porous. Okay, that's why the excellent solubility will be there. Then yes, drying of sterile products. Again, you have to remember this drying of sterile products. The question is being asked that explain the equipments which are used for the production of sterile materials. So you have to list out all the equipments and then you have to explain any one. So yes, drying of sterile products. Then last is making powders to form reconstituted products. Now, what are these reconstituted products? If we talk about reconstituted products, then there are two types. Two mainly reconstituted products are used. First is reconstituted suspension, and second is reconstituted emulsion. In that also, more often used is reconstituted suspension. Now, what is this reconstituted suspension? Normally, how suspension is, there is one solid phase, one liquid phase. The solid particles are suspended into liquid phase, that is known as suspension, right? Now, this reconstituted suspension will be in powdered form. Okay, that will be in powdered form. When you want to make suspension, what you have to do, you have to add WFI or any specific vehicle. What is WFI? That is water for injection. Okay, so water for injection or any other suitable vehicle you have to add in that bottle only in which the powder is supplied. You have to add that liquid and you have to just shake it and you'll get your suspension. So this is known as reconstituted suspension. Okay, so this kind of dryers are used to produce reconstituted powders. Okay, if we talk about disadvantages, then it is very bulky and expensive, not always easy to operate, and thermal efficiency is low as much of the heat is lost during process. Okay, so these are the disadvantages of spray dryer. So for the spray dryer, we studied about principle, its diagram, construction, working, then uses, advantages, and disadvantages. To have more clear idea, again, I have given a link. You can click on that link and you can see the video. Now, next dryer today we are going to study is FBD, that is fluidized bed dryer. Okay, let's catch words. Fluidized bed dryer. Now, I guess you might have studied this dryer in size reduction chapter. You might have. Okay, fluidized bed dryer. As name suggests, there is a bed in form of fluidized state. Okay, that means your particle will remain in fluidized state and they will get dry. Okay, again, before understanding principle, let's study about the diagram. This is a fluidized bed dryer unit, this whole unit. Okay, now this is inlet for the air. That air passes through air heaters. Your one more step can be there, that is filters. Filters can be there to filter air. Okay, so your air passes through filter. Then these are the heaters that will heat it up. Then this is the path from which air passes. So from your air goes to this way. This is a perforated bowl that is for the material, to load material. So the products which you want to dry has to be, sorry, the materials which you want to dry has to be keep pure. And then what happens? The air will flow, all the particles, means air, because of velocity, all the particles will remain in suspended form. They will not settle down. They will be in suspended form. Once you get your desired weight, the material or sorry, after a specific time period, what happens? The all the particles will be dried and you can collect them. Now, above this bowl, this is filter bag. Okay, this filter bags are made up of cloth or some a very fine plastic material. Why these filter bags are there? Because once you are done with the process or when you are doing this process, what happens? Some particles will be reduced in size. So those particles sorry, can entrapped in this bag. Okay, and the air. These are the bags, so filter bags. That's why the solid particles will be retained and air will pass through this, and this is the outlet from where air will be out. Okay, and this is the fan that will keep your air circulated. So this is fluidized bed dryer. Now let's understand principle. In fluidized bed dryer, the hot air is passed at high pressure through a perforated bottom of the container containing granules to be dried. The granules are lifted from the bottom and suspended in the stream of air. This condition is called fluidized state. What is fluidized state? The granules are lifted from the bottom and suspended in the stream of air. This condition is called fluidized state. The hot gas surrounds every granule to completely dry them. Thus, materials or granules are uniformly dried. Okay, so this is principle. Construction, I have already explained you. I'm not going into detail. Working, also I have explained you, so I'm not going into detail. Let's see uses for the drying of granules in the production of tablet. Then three operations such as mixing, granulation, and drying are done together. And yes, lastly, with some modification, this equipment can also be used for tablet coating. Okay, so these are the uses. Now, if we talk about advantages, it is less time consuming, available in different sizes, ranging from drying capacity ranging from 5 to 200 kg per hour. That means you can have small unit as well as you can have larger unit. Okay, small units are actually for the lab scale, whereas large units are for industrial scale. Then thermal efficiency is 2 to 6 times more than tray dryer. Hot spots or cold spots are not observed. I've already explained you what are the hot spots and what are the cold spots. Hard drying temperatures can be obtained. Drying of thermolabile substances can be done. So yes, spray dryer as well as this fluidized bed dryer both can be used for drying of thermolabile substances. Then can be operated either as batch process or continuous process, high output from a small floor space. Then disadvantages. Fluidized state may cause attrition effect resulting into production of fines, and many organic powders may develop electrostatic charge during drying. So these are the two main disadvantages. Yes, of course, when they are in when they are in fluidized state, attrition chances of attrition increases, and at the same time, many organic compounds they also develop electrostatic charge. Okay, so which can hinder drying process. That's why, or flowing, what you can say, flow property can also be hindered due to electrostatic charge. Okay, so these are the two main disadvantages. So, for the fluidized bed dryer, we saw principle, diagram, construction, working, uses, advantages, and disadvantages. I've also given a link here. If you click on that link, you'll have a video of the fluidized bed dryer of actual industrial scale. So for more clear idea, you can see that. If you have any doubt regarding spray dryer or fluidized bed dryer, you can ask me. Stay home, stay safe, and keep reading. Thank you.